Our goal in the beginning of chapter 6 is to be able to use ratios and proportions to write and solve equations. We will be able to identify similar polygons and use them to find missing side lengths and angle measures. We just spent a unit talking about congruent polygons. Let's recall what that means. Congruent figures have the same shape and the same size. Well, if they have the same shape, that means that the angles are congruent. If they have the same size, that means the sides are congruent. When figures are similar, they're not exactly the same in all ways. They also have the same shape, which means the angles must be congruent, but they don't have the same size. They're different sizes. But in order to have the same shape, there still has to be some sort of correspondence, some sort of relationship of their sides. So the way we describe that is we say the sides are proportional. So now as we're studying similar polygons, remember that for similar polygons, the angles must be congruent while the sides must be proportional. Let's take a look at how to describe two similar figures. This picture shows two similar triangles. How do I know they're similar? From the similarity statement. This statement right here, triangle ABC is similar to triangle DEF. Notice how it's like the congruent symbol. Remember, the congruent symbol is an equals with the squiggly on top. Similar symbol is just the squiggly. So see, we say it's same shape, but different size, whereas congruent is the same shape and the same size. So a lot more stuff is the same, it gets an equals, whereas similar, not everything is the same. So there's that similarity symbol right there that's telling me these triangles are similar. Just like a congruent statement, this is telling me something about the triangles. Specifically, this shows that the triangles, or figures in general, are similar and which parts correspond to each other. So which parts I can match up. Match up to make a statement of proportionality. Remember what a proportion is. A proportion contains ratios and an equal sign. So remember that we said a pair of similar polygons has sides that are proportional. Well, what does that mean? Let's take a look at the statement so I can see which sides match up, such as AB and DE. AB is this side, DE is this side. They're not the same as each other. Can you tell how they compare? I'm going to give you a minute to try to answer that. So AB matches up with DE. Notice those numbers in relationship to each other. How about BC and EF? Look at this number and this number. How do they relate to each other? Are you starting to see a pattern? 6 is twice as big as 3. 8 is twice as big as 4. The last pair that we didn't match up, 4 is twice as big as 2. That's what we mean about the sides being proportional, and that's how we show it. AB over the corresponding side DE is equal to the ratio of the other two corresponding sides. BC over EF and AC and DF. AC over DF. Just with the letters, it's not as obvious, so let's put the numbers in there to help it make a little bit more sense. Like we said, AB corresponds with DE. So if I write 6 over 3, that should be equal to BC over EF. BC says 8, EF says 4, 8 over 4, and then the last pair of corresponding sides, 4 and 2. Well, just a glance at these numbers, and you say, well, those aren't equal, but let's reduce it. 6 over 3 makes 2 over 1, 8 over 4 makes 2 over 1, and 4 over 2 makes 2 over 1. All of them make the same ratio. That's how we tell that the sides are proportional. And that ratio is the scale factor. So for this example, the scale factor is 2 over 1. Another way that that scale factor can be written is 2 to 1 with a colon like that. So how do we describe what are these things? A statement of proportionality shows the ratios of the corresponding side lengths. The scale factor is the ratio of the lengths of two corresponding sides for the similar polygons. A dilation is kind of another way to say the scale factor. A dilation means a stretching or a shrinking from one figure to the next. So if we go from left to right, if we dilate this figure to change its size, it's shrinking. So how can we describe how this triangle on the left, as we move to the right, how it dilates? We could say triangle ABC is dilated by a factor of 2 from triangle DEF. That means this is twice as big as the smaller triangle. If I said it the other way, I could say triangle DEF is dilated, which just means a stretching or a shrinking, by a factor of 1/2 from triangle ABC. Why? Because this triangle is 1/2 as big as the first triangle. Let's do a quick review of ratios and proportions, since we're going to need to use them a lot with similar figures. A ratio is simply an expression. Often we see it like a fraction that relates to quantities, an expression relating to quantities. So different ways that it can be written are like how we showed the fraction, like 2 over 3, or 2 to 3, or literally using the word 2, like that. So 3 different ways: a fraction, with a colon, or with words. Let's look at this more simple example. Write and simplify the ratio of the width to the length of the rectangle. The width to the length. Now, normally the width and the length can be interchanged in a rectangle, but let's consider it as the width being the short side. This will be the width, and the length being the long side, even though they can go either way. So if I write the ratio, usually it's more it's simpler to write it as a fraction. So the width, 8 inches, we can put on top, and the length, 2 feet, we can put on the bottom. Now we can keep it in different units and just reduce the numbers. So 2 goes into 8 4 times evenly, and 2 goes into itself 1 time. So this could be 4 inches for every foot, but usually it's easier to translate them and have them in the same units. So in the same units, we need to translate the feet into inches. 1 foot consists of 12 inches. So if I change it so it's in the same units, then I have 4/12 and reduce to 1/3. So this is the ratio of 1 to 3 from the width to the length. Or write it with a colon or with words. Either way is good. Let's review proportions. A proportion is taking two ratios and putting them together in an equation. So a proportion is just an equation relating two ratios. So what can that look like? Well, just using letters, maybe like A over B equals C over D. How do we solve proportions? The cross product property. So you've probably heard of that as cross multiplying. So just a quick review of what that looks like. If I write A over B equals C over D, I'm going to multiply across like that. So I get A times D, and then it will equal, when I multiply across the equal sign the other way, C times B, or B times C. Let's practice. Maybe you try these on your own, see if you can remember how to do them, and come back and check your work. Use the properties of proportions to simplify and solve the following proportions. So I want to solve for y. So I'm going to cross multiply. Maybe multiply across this way first because it has the y in it. 5 times y I should write as 5y equals, and then if I cross the other way, 3 times 50 is 150. Then all I have to do is divide both sides by 5 and y equals 30. Not too bad, right? Now, if we look at the next one, we've got more than just one thing up here. We have two terms that are being added. So immediately when I see more than one, I'm going to put it in parentheses. Then I'm going to cross multiply. So I'm going to multiply these across. So I'm going to write 300 parentheses y plus 2 equals, and then crossing the other way, y times 500, or 500y. So I don't really need the parentheses here because I'm not containing anything. So just 500y is fine there. Always the parentheses when I have adding or subtracting or more than one number or letter together. Then I'll remember that I'm supposed to distribute in this equation. So then I get 300y plus 600 equals 500y. And then I want my y's together. So minus 300y, and 600 equals 200y. Geez, these are big numbers. I wish there was an easier way to do this. Oh, do you? Well, guess what? There is. So we get y equals 3. Now, if you don't want to work with big numbers, listen closely. Remember how when we multiplied this way, first I wrote y times 500, and then I said, but it doesn't need to be that way. It can be 500 times y. Well, it doesn't matter how we multiply these. 500 and y still get multiplied together. So does it matter then if I have y down here and 500 up here? Am I still going to be multiplying y and 500? Yes, I am. Now, why would I want to switch it? That's a good question. Let's look at what it looks like if I did switch it. So I'm going to put y plus 2 still on the top over here, but now y is on the bottom, equals 500 over 300. How is switching it helpful? Well, remember how we reduced ratios earlier? Now this ratio can be reduced. 100 goes into 500 and into 300. And look at that. I have a much simpler equation. Y plus 2 over y equals 5 over 3. Now when I cross multiply, my numbers are smaller. Still remember, put the parentheses when we have two things added or subtracted, or more than one thing. And now I can solve this equation, and it's easier. So cross multiply, 3 times parentheses y plus 2 equals, cross multiply the other way, 5 times y. This is going to be much easier. Look at what happens when I distribute. My numbers are smaller. 3 times y is 3y. 3 times 2 is 6, so 3y plus 6 equals 5y. Now when I subtract, I'm not subtracting hundreds, I'm just subtracting 3y. And let's relocate a little bit here so we have more room. 6 equals 2y, and dividing by 2, y equals 3. And my numbers were simpler. Same answers, but my numbers were simpler. Just a thought. Maybe try number 3 on your own. Come back and see how you did. Did you get that y equals 15? If not, stick around and check your process. Let's look at another one. This one is given that BC to AB is in the ratio of 1 to 2. Find AC. This length right here is what we need to find. This is a ratio and this is a ratio. This can be translated into an equation. BC to AB. Remember how a ratio can be written as a fraction. Is translates into an equal sign if we need it. 1 over 2 instead of 1 colon 2. BC means the length of BC. BC is this guy right here, says 4. Substitute. AB is this guy right here, says x plus 4. Substitute, plug it in. Equals 1 over 2. We just reviewed solving proportions. I bet you can solve this. I see x plus 4 right away. Put parentheses before we cross multiply. Then cross multiplying will be easier. X plus 4 times 1. I put the parentheses just out of habit, but really we know that's the same as just x plus 4. Anything times 1 is itself. Cross multiply the other way, and that is 8. It looks like x equals 4. But let's go and answer the final question. Find AC. AC is this one right here, which says 2x. So now that we know x, AC, which is 2x, is 2 times 4, or 8. AC is 8. Always look at the question. Don't just stop when you find x. Let's look at another one. This one says that triangle ABC is similar to triangle EDC. This shows us our corresponding parts. They want us to find DC. That's the side. So finding DC, that's the side labeled X. Our statement helps us match up the corresponding parts. So let's see. If I want to find DC, I want to match it up with a part that it corresponds to so I can make a proportion. Look at where DC is and look at what it corresponds to. So I could say DC over BC. And what other parts can it correspond to? Well, I would like to match it up with a pair of sides that has numbers, such as this side that says EC. Well, the E and the C match up with the A and the C. So EC over AC, this side right here. Now I'm going to do some substituting of what these are. So EC we said is 4. AC we said is 8. And that will be equal to DC, which says X, over BC, which, it doesn't say anything. Well, from B all the way to D, it says 10. So how much does this leftover piece have to be? All the way across is 10. Take away this part we don't want, which says X, and leftover is this. When we take away, what is that? Subtraction. So we're going to call this 10, take away the part that's next to it. The whole way is 10. The part next to it that we want to take away is x. So 10 minus x. And now all we have to do is cross multiply. Remember to stick those parentheses in there where we're subtracting or adding more than one number or variable. And now we can cross multiply. 8x equals 4 times 10 minus x. Distribute. 8x equals 40 minus 4x. Get our x's on the same side. And get x by itself. So x is 10/3. If we use our calculator, it'd be a run-on decimal. So I'm just going to leave it as 10/3. Says find DC, and DC says x. So I will write that DC equals 10/3. Let's try a few more. Number 6, given the similarity statement, ABCD is similar to WXYZ, write a statement of proportionality. So all we have to do is look at the statement to match that up. I don't even need the picture. AB over WX equals, what's the next pair of sides? BC and XY. BC over XY. Equals, now we could look at the picture and go AB, what's next? BC, what's next? CD and DA, but the statement will do it too. Can you finish the statement of proportionality? Pause the video, see how you did. Next, find the scale factor. Well, how do we find the scale factor? That's the numbers. So basically anything where we see numbers, let's just substitute those numbers into our statement of proportionality, such as DA says 14. ZW says 10. XW says 8. XY says 4. ZY says 3. All my numbers in there. Then take the ratio that has numbers in the top and bottom, and that's our scale factor after we reduce it. 14 over 10 makes 7 over 5. 7 over 5 is our scale factor, or we can write it with the colon. But we always go left to right. The statement and the picture going left to right. Now we're going to find the values of the missing side lengths. Again, we can go to our statement of proportionality and make proportions using our scale factor. Meaning, I need this side, I don't have it. So I'm going to write AB over 8 is on the bottom instead of WX because I knew that WX is 8 from the picture, equals the scale factor. I also need BC, so I'm going to make a proportion with that. BC over 4 equals the scale factor. I also need CD. CD over 3 equals the scale factor. Now I can cross multiply to solve these proportions. So 5 times AB equals 56. I need the AB to be by itself, so I'll divide both sides by 5. And using my skills of division, I know that AB equals 11.2. Try the other ones, see if you get them right. Did you get them? If not, check out the work. Let's take a look ahead. Eventually, we're going to be finding perimeters of objects. Let's do that now, just to do some comparison. What does perimeter mean? The measure around the figure. Think of it as a length, putting all the lengths together. So the first figure, I found these side lengths, 11.2, 5.6, 4.2. So all I have to do is add them up. The perimeter of ABCD is simply adding up all the sides. 11.2 plus 5.6 plus 4.2 plus 14, and that's 35. The perimeter of the smaller figure, WXYZ, take all those sides and add them up. 10 plus 3 plus 4 plus 8, and that's 25. Well, those numbers may not seem significant, but let's look at them closer. If I make a ratio out of 35 and 25, what do we see that happens? What is special about the perimeters of the similar polygons? Let's take this ratio and reduce it. What does it make? Do you notice something special about that number? That's right, it's the scale factor. The ratio of the perimeters is the same as the scale factors, or the ratio of the corresponding side lengths. Keep that in mind as we move on into the next section. Let's try one more. Are these polygons similar? This time I'm not telling you the answer, I'm asking you a yes or no question. If so, then we'll do the following. So recall back to the beginning when we said what similar polygons means. Angles have to be congruent and sides have to be proportional. Are the angles congruent? That's our first question. Are the angles congruent? I'm going to put a question mark here because we don't know yet. I see a congruent mark for that pair and a congruent mark for that pair, but that's all. But what about the third angles theorem? If the two angles are congruent to the two angles, the third angles must be congruent as well. So yes, the angles are congruent. Second question, are the sides proportional? How do we figure that out? Matching up the ones that correspond. Corresponding, well, let's look at these three sides. Which side is the smallest? 6. Of these three sides, which one is the smallest? 4.5. 6 over 4.5. Grab your calculator if you want to help reduce that fraction. Math, enter, enter, reduce the fraction, 4/3. Let's take another pair of corresponding sides. Medium length, medium length. 8 over 6, 4/3. Start to see a pattern? How about the large sides? 12 over 9. Also 4/3. So notice that we're getting 4/3. So the sides, when we make ratios, all equal each other. So the sides are proportional, yes. Write a similarity statement. Triangle. So anyway we want to write this first one, maybe alphabetically, LMN. Similar to triangle, can you match up the corresponding parts? Let's see how we went. LMN. We went medium to small side, or we can say double slash, single slash, triple slash, 2, 1, 3. How do we do it here? 2, 1, 3. TPO. Scale factor? That's easy. We already figured it out when we reduced the sides. 4 over 3. Not bad, right? Time to write a summary. Take a moment to describe where, outside of the classroom, that you see similar figures. See you in class.